Hello viewers, you're welcome once again to my YouTube video. Today I'm going to estimate the mode from a histogram. I'll read out the problem. The results of a continuous assessment test administered to 505 first-year mechanical engineering students at the school are listed in the table below. Construct a histogram and use the histogram to estimate the mode. Now, to solve this problem, I need to write out this frequency table. Okay, so I have my frequency table and I created two more columns. Now, the essence of creating these two columns is to help me to be able to get the sufficient data that I need to plot, or rather to construct my histogram. Okay, so the column next to the frequency will be the class boundary. So I give it the name CB, class boundary. Okay. So for me to get a class boundary, of course, I need to get the lower class boundaries of each of the 5 classes and the upper class boundaries of each of the 5 classes. So to do that, I'm going to make use of the first column signifying the marks of students in the continuous assessment test. Okay. First, I need to check the trend between the upper class limits of a class and the lower class limit of the next class. So if you look at the upper class limit of this first class is 15, right? The lower class limit of the next is 16. So the lower class limit is one more than the upper class limit. Look at the next, the lower class limit of the third class is one more than the upper class limit of the second class. Okay, the lower class limit of the fourth class, 26, is one more than the upper class limit of the third class. And then the lower class limit of the fifth class, 31, is one more than the upper class limit of the fourth class. So you can see the trend. The lower class limits are one more than the upper class limit of the previous classes. Okay, so if I need to get the first value here, which is the lower class boundary of the first class, I need to assume the existence of a class before the first class. Okay, if I do that, the upper class limit of this class that I'm going to assume should be 0, so that the trend will be correct. 0 to 1, 15 to 16, 20 to 21, 25 to 26, 30 to 31. So if there exists another class here, it will be 40 to 41, right? Okay, so I can make use of 0. Now I'll find a midpoint between that value, the 0, and this one. So I'll write out my 0 plus 1 divided by 2. This boils down to 1 divided by 2, which equals 0.5. So the lower class boundary of the first class will be 0.5. Okay, now I'll clean this up. To get the other value, I'll find a midpoint between the upper class limit of the first class and the lower class limit of the second class. So I'll work with 15 plus 16 divided by 2. This equals 31 divided by 2. This boils down to 15.5. So I'll write out my 15.5 as the upper class boundary of the first class and the lower class boundary of the second class. Of course, I got these two values from the midpoint of 15 and 16. I'll clean this up and then I pick the next value, 20 plus 21 divided by 2 equals 41 divided by 2. This boils down to 20.5. And write it here as the upper class boundary of the second class and the lower class boundary of the third class. Okay, I'll clean this up. Work with 25 and 26. So 25 plus 26 divided by 2 equals 51 divided by 2. This boils down to 25.5. That will be the upper class boundary of the third class and the lower class boundary of the fourth class. Okay, I'll clean this up. Pick the next value, 30 plus 31 divided by 2 equals 61 divided by 2. And this boils down to 30.5. This is the upper class boundary of the third class, the fourth class, and the lower class boundary of the fifth class. Okay, I'll clean this up and then I'll pick 40. Of course, if there exists another value, the lower class limit of that value beneath the fifth class will most likely be 41. So 40 plus 41 divided by 2 equals 81 divided by 2, and this boils down to 40.5. So I'll write it here. So my class boundary column is all set. Now, ordinarily, I need to pause here, right? because I can make use of this class boundary on the horizontal axis and the frequency on the vertical axis. But to do that, I need to be sure that my class boundary, each of the 5 classes, have the same class sizes. Okay, so let me test. The first class, 15.5 minus 0.5 is 15. Okay, the second class, 20.5 minus 15.5 is 5. The third class, 25.5 minus 20.5 is 5. The fourth class, 30.5 minus 25.5 is 5. And the fifth class, 40.5 minus 30.5 is 10. So as we can see, the first class is having a class size of 15, the second class 5, the third class 5, the fourth class 5, and the fifth class is 10. So we have inconsistent class sizes. Because of the inconsistency in the class sizes, we can't make use of the frequency on the vertical axis. We have to create another column and we'll give it a name, frequency density, FD, frequency density. Now, the formula for frequency density equals the ratio of the frequency of the class in question to the class width of that same class. Okay, another word for class size is class width. Take note. So when I use class width, class size, I mean the same thing. Okay, so without wasting time, I'll clean this up. To get the first value under the frequency density column, I'll write out my 90 divided by 15, where 90 signifies the frequency of the first class and 15 signifies the class width of the first class. This boils down to 6. So I'll write out my 6 under the frequency density column. I'll clean this up. The next value is 60 divided by 5, where 60 is the frequency of the second class and 5 is the class size or the class width of the second class. This boils down to 12. I'll write out my 12 here and then I'll clean this up. The next value, I'll work with 110 divided by 5. 110, by the way, is the frequency of the third class and 5 is the class width of the third class. Okay, this boils down to 22. I'll write out my 22 and then I'll clean this up. I pick the next value, 85 divided by 5. 85 is the class frequency, or rather the frequency of the fourth class, and 5 is the class width of the fourth class. Okay, this boils down to 17. So I'll write my 17 under the frequency density column. I'll clean this up. And then the last value is 160 divided by 10. 160 is the frequency of the fifth class. 10 is the class width of the fifth class. This boils down to 16. I'll write it here. So my frequency density column is set. Same with my class boundary. Now I am prepared to draw my or construct my histogram. So I'll bring out my graph sheets. I write out my columns. I have my vertical axis and the horizontal axis. Because of the variation or the unequal class sizes or unequal class width of the different classes we have, I'm not going to make use of the frequency on the vertical axis. I'll rather use the frequency density, and the horizontal axis will be the class boundary. Okay, so I'll use 2 centimeters to represent 5 units on the vertical axis, starting from 0 to 5. So I have 10 divisions over here: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And for every 2 centimeters, I'm representing it with 5. So 5 divided by 10 is 0.5. So each division is 0.5. So 0.5 times 2 is 1, times 3, 1.5, times 4 is 2, and then we can go on and on until we get to 5. So the next value will be 10, 15, 25, and then, or rather 20 and 25. So this axis is the frequency density axis. That's the vertical axis. The horizontal axis, I'm going to use 2 centimeters to represent 10 units. So I'll start with 0.5, 10.5, 20.5, 30.5, 40.5, and this represents the values born out of the class boundary. But these values were derived from the marks obtained by students. So I can give the horizontal axis the name marks, okay, obtained by the 505 students. Now, looking at the horizontal axis, what is the smallest value? Since I'm using 2 centimeters to represent 10 units, that is 10.5 minus 0.5 is 10. Okay, 10 divided by 10 is 1. So each small division is 1. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so it's easier for us to read the horizontal axis, right? And same with the vertical axis, since we have gotten the smallest division. Now, I'll start constructing my bar. The first bar is having a class width or the class size of 15. 15.5 minus 0.5 is 15. So I'll have 1, 2, 3 centimeters to represent that, right? Okay, and the height is 6. So if here is 5, 5.5, 6. So I'll construct my first bar. The next bar, having a frequency density of 12, starts from 15.5 to 20.5. So, and the height of the bar is 12. So I have 10, 11, and then 12. So my second bar is all set. The next bar is having a height of 22, which is equivalent to the frequency density. And it starts from 20.5 to, it stops at 25.5, somewhere here. And the height is 22. So if here is 20, 21, 22. And then I construct my third bar. To construct the fourth bar, I need to work from the bar will span from 25.5 to 30.5, and the height of the bar is 17. So I have 15, 16, 17. Now for the last bar, the frequency density for the last bar is 16. So I'll start from 30.5 and to end at 40.5, and the height is 16. So 15, 16. So my histogram is all set. Now to construct to estimate the mode from the histogram, I need to join the straight line from this vertex to this vertex. That's the vertices of the tallest bar. I will join it with the vertex of the other bars attached to the tallest bar. So from this vertex to this vertex, from this vertex to this vertex. So I'll construct my first one from this vertex to this vertex, and then the next one from this vertex to this vertex. These two lines intersect at a point, so I will join the point to the horizontal axis with a straight line. Okay, these thin short dashes represent the point of intersection of these two bars. And then the point where it hits the max axis, I'll read it from the horizontal axis. Since the value I have here, the beginning of the bar is 20.5, therefore to estimate the mode, I'll write out my 20.5 plus, from here to here, we have agreed that we have 2 centimeters to 10 units, and each small division equals 1. So I have 1, 2, 3, 3.5. So I write 3.5. The summation boils down to 24. Hence, the mode of the estimated mode from the histogram equals 24. I do hope the solution was very helpful to you. If you have not subscribed to my YouTube channel, kindly do so. The name is Victorian STEM, and I have a couple of videos that I feel if you go through, they'll be helpful to you. And if you have not shared it, kindly share it with your friends so they could see our solutions. And we appreciate your dropping your comments on the comment section. And if you have any question, feel free to ask. Thank you for watching my YouTube video. Do enjoy your day. Bye bye.